Welcome back, smart mathematicians. Let's do question 1.3. This question is perfect when you're preparing for your end of year examinations because it involves a lot of topics, and also there is a concept that is done in paper 2 that you have to apply here. There's Euclidean geometry in it, and also completing the square. Maybe by now you haven't done those. The diagram below shows a circle with center O that passes through the vertices A, B, C. AB is the diameter, and then AC is x plus 3, we can see that, and then BC is 5 minus x units, you can see that. Calculate the value of x that will make AB the diameter a minimum length. So when you're given this, that AB is the diameter of the circle, we talk about angles in Euclidean geometry. You do this one later, right? Angle is subtended by diameter, and angle subtended by diameter is 90 degrees. We will say an angle in what? In a semicircle. So it means that this angle here is 90 degrees. You see that? So we can say, remember Euclidean geometry, we write our reasons. So angle C is equal to 90 degrees. And then we say angle in semicircle. Okay, just know that it's a theorem. And then, so it means what type of a triangle is triangle ABC? ABC is therefore a what? A right angle triangle. And then with a right angle triangle, remember the Pythagoras theorem, right? Which side is the hypotenuse here? If you look at triangle ABC, it is AB. This is the hypotenuse. The side opposite the 90-degree angle. The side opposite the 90-degree angle is the hypotenuse. So this side squared, AB squared, is equal to AC squared plus BC squared. Why are we saying that? Because of the Pythagoras theorem. Pythagoras theorem. AB squared is equal to AC is x plus 3, x plus 3 squared plus BC 5 minus x squared. And then AB squared is equal to, and then we say this is x plus 3 squared. So we say we square the x here is going to be x squared. And we take this sign here, which is plus, and then say 2 times x times 3. 2 times x times 3, which is 6x. And then we square the last term, and then we get positive 9. Okay, we have expanded this part. And then we come here, plus 5 squared is 25. And then take this sign, which is negative. And then 2 times 5 times x is negative 10x here. Then this one is always positive. And then square the x, which is x squared. If the shorter way of expanding a square binomial is giving problems, remember, you can do this. 5 minus x squared is 5 minus x times 5 minus x. Can as well do this. Okay, expand that, expand, like that, distribute that. 5 times 5, 25. 5 times negative x, negative 5x. Negative x times 5, negative 5x. Negative x times negative x, positive x squared. You see that? You get 25 minus 10x plus x squared. You can do the long way. You can also do with what? With x plus 3 squared, you will get this x squared plus 6x minus x squared plus 6x plus 9. Right, let's collect the like terms. AB squared is equal to x squared plus x squared. That is 2x squared. Then 6x minus 10x, that is negative 4x. And then 9 plus 25, that is positive 34. So we have to know that AB is going to be minimum when AB squared is minimum. AB is going to be the minimum when AB squared is minimum. So let's find the minimum point for AB squared. This is AB squared. Okay. And then what type of a graph is this? This is a concave graph like this, which is what? which is concave up, and it is a minimum point. Then how do you find the coordinates of the minimum point? We can use the axis of symmetry or use completing the square. Right, we can complete the square or use the axis of symmetry. Let's start by completing the square, and then after completing the square, we're going to use the axis of symmetry method. But remember, our AP squared is this, so we're going to be using this equation. By using this equation, let's complete the square. So when you're completing the square, the coefficient of x squared must be 1. So here we have to factor out 2. Okay, we factor it out. It doesn't disappear. We're just changing a form here from one form to the other. We're not solving equations. When you're solving the equations, then you can divide everything by 2 and then it disappears. But here we're changing from this form, the standard form, to the turning point form. Okay, right. So the 2 must be outside the bracket. So it's AP squared is equal to 2, and then x squared minus 2x plus 17 in the bracket. And then we deal with this. We completely square this one, which is inside the bracket there. Don't forget we have a 2 here. So let me try to do it here. So it's AB squared is equal to 2. And then what do we do? Find half of negative 2. Find half of negative 2, which is negative 1. And then you square it, and then you add and subtract it. Can I say there are 4 operations you have to remember here? That you have the coefficient of x, 1, you square it, 2, and then you add it, 3, and then subtract it. Half of negative 2 is negative 1. Then what do we do to it? We square it. And then after squaring it, we add it and subtract it. Just remember that. We have our x squared here, and then minus 2x, and then we said we find half of negative 2, which is negative 1. We square it, and then we add and subtract it. So it's going to be, and then subtract it. Negative 1 squared, and then plus 17. Right, and then AP squared is equal to 2. It is very easy to factorize this. It is very easy. You just take this x and this negative 1, forms your bracket, becomes x minus 1, and then squared. Okay, it is the opposite of the square binomial thing. Let me show you something. Let's say we have x squared minus 2x, and then negative 1 squared is 1, positive 1. Okay, so what are the factors of positive 1 that will give us negative 2? Is negative 1, negative 1. So it's x minus 1, x minus 1. You see that? Which is x minus 1 squared. If you factorize these first 3 terms. So the faster way, you just take the x here, you take this term inside the bracket here, then they form a bracket, then you're done. And then minus negative 1 squared is 1 plus 17. Get our AP squared is equal to 2, then x minus 1 squared plus 16. Right, remember we have 2 outside here. Inside the square bracket, how many terms do we have? We have 2 terms, this term and this term. So we distribute the 2. We distribute the 2. So AP squared is equal to 2x minus 1 squared plus 32. What are the coordinates of the turning point of AP? Right, we can get the coordinates of the turning point here. TP for turning point, TP for turning point. This is the x coordinate. This is the x coordinate. If you have a equation in the form f of x is equal to a x minus p squared plus q, then means your coordinates of the turning point will be pq. See that? Changes sign. If it's negative here, then it's positive there. So it means the turning point will be 132. So it means AP squared is minimum when x is equal to 1. Therefore, AP squared is minimum when x is equal to 1. Therefore, AP squared here, not AP. Therefore, if AP squared is minimum when x equal to 1, it means AP also is minimum there. Is minimum when x is equal to 1. Let's do the second method. Remember, we're going to use this. We said AB squared is equal to this, so we're going to start from there. AB squared is equal to 2x squared minus 4x plus 34. Right, you can use the axis of symmetry. Remember, for the axis of symmetry, x is equal to negative b over 2a. So this one was easier. X is equal to negative, your b is negative 4. So negative 4 over 2 times a, 2. So which is 4 over 4, which is equal to 1. So x is equal to 1. So that's the axis of symmetry. The axis of symmetry passes through the turning point. It passes through the turning point. So it means when x is equal to 1 here, when x is equal to 1 here, this is the minimum point. So it means therefore AB squared is minimum when x is equal to 1. Therefore AB is minimum when x is equal to 1.